All right, so we have here the definition of vertical asymptote and the definition of horizontal asymptote. This can be a little bit confusing, but I'll go ahead and point out and explain each of these definitions by looking at the graph and a example. So here we have definition of a vertical asymptote, and it says the line x equals a is a vertical asymptote. So we should know that x equals a is a vertical line. X equals a is a vertical line. So as you can see here, the dotted line, I'll point it out right here, that the vertical line at x equals 2 is a vertical asymptote. So the idea with the vertical asymptote, as mentioned in this definition, it's the graph of a function f. So the line x equals a, the vertical asymptote of the graph of the function f, provided that f of x, and now this line means approaches infinity. So as it approaches, it just goes up and up and up and up forever. Or if the function approaches negative infinity, goes down, down, down forever. So that's referring to the vertical solution. As you can see, it is going down forever. It's going towards, so it's going down vertically forever. And assuming that it's x is approaching a, so as we can see, x is approaching 2. As you can see, the function is approaching x equals 2, but never actually touches it. So we can see that for this function, this example here, it is approaching x equals 2, the function being the blue line here. The function is approaching x equals 2 as it approaches negative infinity for the output and positive infinity up here. Now, it doesn't have to do both. It's or. It could be one or both. So it could actually be, it could actually look like this. It could be, oh my gosh. It could be approaching positive infinity, both from the negative and positive direction. But we'll notice that in this case, it's approaching negative infinity and positive infinity for this graph. But we should notice that this would be called a vertical asymptote because it never actually touches the line x equals 2, but it approaches it. But it never actually touches it. So that's known as a vertical asymptote. And then the horizontal asymptote is very similar, but we're talking about a horizontal line opposed to a vertical line at y equals b. So in this case, in this line, we have y equals 1, and this dotted line would be our horizontal asymptote. And as we can see, it is approaching the function f. It's the horizontal asymptote of the graph function f, provided that f of x approaches b. So the function approaches b some value, which is in this case 1. So it's approaching 1 in this case as x approaches infinity or x approaches negative infinity. So it's approaching negative infinity for x and positive infinity. In this case, it's approaching both. And but it never actually touches y equals 1. So that's the idea with asymptotes. It never actually touches the value. In a vertical asymptote, it's not actually going to touch some x value. In horizontal asymptote, it's not going to actually touch some y value, but it's going to come very, very close. So you'll notice that we have the same sort of attributes when we're talking about either vertical or horizontal asymptote. And we'll get into something called slant asymptote, which is a slanted line, not a horizontal or vertical line. It'll be slanted, and it'll never touch that slanted line. So we'll get to that in the last slide. But in the next 2 slides, we'll be discussing further the vertical and horizontal asymptotes and how that relates to the function. As we can see, this is the function here. We don't actually know at this point why this function gives us these two vertical, this vertical and horizontal asymptote. but we will see that in the next two slides, and we'll break that down. All right, so you may want to refer back to this video and see that you understand this after you look at the next two slides. So you should make sense of this and understand why this function will give you these two asymptotes, but it should make sense more after you review the next two slides. All right, let me know if you have any concerns, and I'll be more than happy to help.